All right, so this is a review for 4.2 in chemistry. As you can see, the average is 26 out of 32 points, but if we look at the distribution of those scores, I have some highs, some middles, and some lows. All right, so I'm going to go through definitely the two most missed questions and some of the other questions that a lot of people seem to miss. All right, the cathode rays were deflected towards a negatively charged metal plate. Okay, so here's the thing. Remember, opposites attract, likes repel. So since the cathode ray itself was negatively charged electrons, all electrons are negative, right? So the cathode ray is negative. If you bring a negatively charged metal plate near it, it will be deflected away from the plate. So this was a false statement. Okay, remember, opposites attract, likes repel. Two negatives would repel each other. All right, this is one we didn't talk a lot about in class, but it was in the textbook, which you're supposed to be reading. The proton was first called a canal ray, and that is true. They noticed that while the cathode ray was going from the cathode to the anode, there was another beam going the other way, and that was the protons. They just didn't know what it was at the time. Just for a moment of positivity, everybody got this one correct. Great job. All right, cathode rays were shown to be streams of blank particles. They're electrons, so they're negatively charged particles because electrons are negative. So that's the answer. Negative particles. Okay. So the importance of this question, or this part of Thompson's experiment, is that it didn't matter. He got the same particles moving through the cathode ray tube regardless of what gas was in the tube. This meant that the particles were coming from the metal cathode, not from the gas. And so it didn't matter which gas was in there, they were still electrons. All right, so electron weighs about blank the mass of a hydrogen. So the actual answer is 1/1840th. So that's the answer you should have given me. 1 out of 2,000 is not a bad answer. It's rounded a bit, but it's not a bad answer. Because that's the textbook answer, but this is the answer we're looking for. Here they put 1 out of 840. So that's wrong, but I think I gave them credit because I assumed it was a typo. Okay. This is not technically wrong, but it's kind of wrong that this is a ratio, but then a fraction is a ratio. So, you know, I think I gave them credit for that. I don't remember offhand. This is wrong. It's wrong. I don't know. This is also wrong. Okay, there's a definitive answer in the textbook, a quantitative answer. And it should have either been this or this. Okay, one or the other. All right, so Rutherford's experiment showed the location of electron. That is false. Rutherford's experiment showed that there was a concentration of mass and positive charge at the center of the atom, and then the rest of the atom was mostly empty space. And he knew the electrons had to be out there, but he didn't know how or where. He just knew they were outside the nucleus. So Bohr's experiment showed the energy levels where the electrons are. Schrodinger added the mathematical aspect, and we got the electron cloud. But Rutherford showed the nucleus, not the electron. All right, so with this one, you had to fill in the missing information. All right, so since the first one says proton, we know the charge is positive, and we know the relative mass is 1. So this second particle, we don't know what it is at first, but we know that it has a charge of 0. So it must be the neutron. And neutrons also have a relative mass of 1. So the third one, logically, has to be an electron. Okay? The relative charge on an electron is negative, and its mass is 1/1840th. By the way, wasn't that the answer to a different question on this? So that was the point there. Okay. I hope this helps. I'll see you in class.